Next, we have question number 2 of exercise 2.3. So let us read the question first. Check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. So we need to check whether this polynomial is a factor of this polynomial or not. Okay, so let us do the long division. If the remainder is coming out to be 0, then we can say that this polynomial is a factor of the other polynomial. Otherwise, it will not be a factor. Okay, so let us perform long division here. The first polynomial is x cube minus 3x plus 1, and the other polynomial is x5 minus 4x cube plus x square plus 3x plus 1. So first step will be x square multiplied by x square, so you will get x5 minus 3x cube and plus x square. Now if you change sign, this will cancel, this will also cancel, and this will be minus x cube. Plus 3x is same, plus 1 is also same. We have just copied down the terms. So next step will be x cube. We will multiply x cube. In order to get x cube here, we will multiply this by minus 1. So we are going to multiply this by minus 1. So we are going to get the terms as minus x cube. Next term will be plus 3x. So we'll get plus 3x here, and then again your minus 1. So if you change sign once again, you will get plus minus plus. This will cancel, and now the remainder is coming out to be 2. So you can see that the remainder is not coming out to be 0. So since remainder is equal to 2, which is not equal to 0, therefore we can say that x cube minus 3x plus 1 is not a factor of the other polynomial, which is x5 minus 4x cube plus x square plus 3x plus 1. Okay, so this was third part of the second question. You can do the remaining parts. Okay, so let us do third question now of the same exercise. Now it says that obtain these type of questions are very important from board's point of view also. So let us understand this. Obtain all other zeros of this polynomial if two of its zeros are given to be this. So let us first write our polynomial like this. It is 3x4 plus 6x cube minus 2x square minus 10x minus 5. So two zeros are given like this. So if this is a zero of this polynomial, we can say that x minus root 5 by 3, this is a factor of px. Okay, this you can say by factor theorem, because this is a zero of this, so it will be a factor. Okay, similarly, and x plus, because of this, x plus 5 by 3 is also a factor of p by px. Okay, so if these two are factors, so the product of these two, x plus root 5 by 3 into x minus root 5 by 3, this will also be a factor of px, which means that if you apply a square minus b square here, so x square minus 5 by 3, basically this polynomial is a factor. Okay, root 5 by 3 ka whole square is, root 5 ka square is 5 and root 3 ka square is 3. So this polynomial is a factor of px. Okay, so let us divide this, because since it is a factor, so it will be exactly divisible like we did in previous question also. So let us divide this. If we divide this polynomial by the factor, which is x square minus 5 by 3, what we will get? Let us see. So we are dividing this polynomial. Okay, so first step will be multiplied by 3x square. You will get 3x4. If you multiply this, you will get 3 and 3 will cancel, minus 5x square. It will be 3 and 3 is going to cancel, so you will get minus 5x square. So it will be like this, minus 5x. So if you change sign, minus plus, again this is cancelling, this is 6x cube, 5 minus 2 is plus 3x square minus 10x minus 5. So on further division, you will get 3, again you will get 6x here, 6x. Okay, 6x से multiply करेंगे तो क्या आ जाएगा? 6x cube, and then you are getting 3 minus 10x, so you are getting this minus 10x. Change sign once again, this will also cancel. We're left with 3x square minus 5. Now we will be multiplying this by 3. So after this you will get 3x square minus 5. You will get the same term, so after cancelling you will get the remainder as 0. It was already said that it is a factor of px, so remainder has to be 0. Now we can apply division algorithm here. So division algorithm says that dividend, which is px here, is divisor into quotient plus remainder. So px equal to x square minus 5 by 3 into quotient. Quotient is 3x square plus 6x plus 3 and remainder plus 0 is the remainder. So we need to find the, what was the question? Let us understand once again. Obtain all the other zeros. We need to find the other zeros of this polynomial. Two zeros are given. Now we have split this, splitted this polynomial px into these two factors. अगर हम इसको 0 put करें, if you put this equal to 0, the zeros are coming out, will be coming like this only, ठीक है, यही दोनों zeros आ जाएगी, but we need to find the other zeros, तो इसको हम 0 put कर देंगे, ठीक है. So for other zeros, we will just substitute 3x square plus 6x plus 3 equal to 0. 3 is common, तो क्या आ जाएगा, x square plus 2x plus 1. Now this you can do by middle term splitting. In this case it is very easy, x and x are the factors, so x is common, you will get x plus 1, again 1 is common from these two terms, x plus 1, so you can in fact apply a plus b whole square also here. Okay, so these are the two factors, x plus 1 equal to 0, so the values of other zeros are minus 1. So all other zeros other than this, the other zeros are minus 1 and minus 1. Okay, so this was question number 3 of exercise 2.3. Okay, let us do one more question based on this. So this is question number 4 of the same exercise again. Now it is given that on dividing x cube minus this polynomial by a polynomial gx, the quotient and remainder, this is a different question. It is already given that on dividing this by gx, the quotient and remainder are already given to be this, okay, and we need to find gx. So if we apply division algorithm here, division algorithm, for applying it, let us write it, let us write this polynomial as px. Okay, so px क्या आ गया हमारे पास, this is px. Okay, so if we divide this by gx, we are dividing it by gx, we are dividing the polynomial px by gx. Okay, gx, the quotient and remainder are coming out to be like this. Okay, so we are given these values, px and rx are given to us. Okay, so by applying division algorithm here, what we are going to get, dividend is px here, dividend is equal to divisor into quotient plus remainder. Okay, so if we apply px equal to gx, what is gx here, what is the value of px here? In fact, we can put the value of px also. What is px here? X cube minus 3x square plus x plus 2. gx we need to find, what is qx here? qx क्या given है, qx any quotient क्या given था हमारे पास x minus 2, and what is remainder, it is minus 2x plus 4. Now if you take this term to the left hand side, so you will get this, ठीक है, you are getting this plus 2x minus 4 and gx into x minus 2 is exactly same. Now just simplify this further, अगर simplify करेंगे तो क्या आ जाएगा, x cube minus 3x square plus 3x, we are just adding the like terms, minus 2 equal to gx times x minus 2. Now we need to find gx here, so you are just going to divide this by x minus 2. So if you divide this by x minus 2, you will get gx. So we just have to perform the long division to get the value of gx. So let us do this. It's very trivial. So on multiplying it by x square, you will get x cube minus 2x square. Now if you change sign, plus minus, this will cancel and this will be minus x square plus 3x minus 2 as it is copied down. So next is minus x, you will get minus x square plus 2x. Now again, after changing the signs, you will get x minus 2, it is exactly same. Now next step will be plus 1, so it will be x minus 2. So if you change sign, again the remainder is coming out to be 0. That has to come 0, because in order that a division algorithm is satisfied. So we need to find gx. So on dividing this by this, the gx is the quotient, whatever the quotient is coming, that is the required gx. Therefore gx equal to x square minus x plus 1. This is the required answer. Okay. The general form of a cubic polynomial is given by px equal to ax cube plus bx square plus cx plus d, where a is not equal to 0. Okay, so let us understand the relationship between the zeros of this polynomial and the coefficients. So we are denoting the zeros by alpha, beta and gamma. These are the zeros of this polynomial px. So sum of these zeros is given by alpha plus beta plus gamma. This is given by minus b upon a. Similarly, S1 is, we are denoting S1 by alpha beta plus beta gamma plus gamma alpha. This is denoted by S1. So this is given by C upon A, and the product of zeros are given by Product of zeros is given by alpha, beta, gamma, which is minus d upon a. Now, if we want to find a polynomial whose either the zeros are given or these values are given, then the formula for finding the polynomial is gx equal to x cube minus sx square plus s1x minus p. So using this formula we can find the required polynomial if the zeros, either the zeros alpha, beta, gamma are given or s, s1 and p are given. Let us start with exercise 2.4 now. So first question says that verify that the numbers given alongside of the cubic polynomials below are their zeros. Also verify the relationship between the zeros and the coefficients in each case. So a polynomial, a cubic polynomial is given and three zeros are given, three numbers are given. We need to verify that these numbers are actually the zeros of this polynomial, and after that we have to verify that relationship. Okay, so let us start with verifying of zeros. So first we will find p2. So what will be p2 here? 2 cube, we just put x as 2, so p2 will be 4 times 2 square plus 5 into 2 minus 2. So if you simplify this, you will get 8 minus, this will be 16 plus 10 minus 2. Okay, so 8 plus 8, 16 minus 16 will be 0. So p2 is 0. It means that 2 is a 0 of this polynomial. Similarly, you can find p1. Now both these zeros are same, so we just need to find one of them. Okay, p1 we can find. So it will be 1 cube minus 4 into 1 square plus 5 into 1 minus 2. Again, 1 minus 4 plus 5 minus 2 is coming out to be 0 once again. So this is, so it means that 2 and 1 both are 2, 1, 1, all these are the zeros of this polynomial px. Now we need to verify the relationship. So alpha is 2 here, beta is 1 and gamma is also 1 because it is same. Okay, so now we have sum of these alpha plus beta plus gamma. So the sum of these will be 1, 2 plus 1 plus 1, which is 4. Now now we have minus b upon a. What is minus b upon a? Before that, let us write a, b and c here. A is 1, b is minus 4, c is 5 and d is minus 2. Okay, minus 2. Okay, so minus b upon a will be minus of minus 4. You can see b is minus 4 here and a is 1, so it is coming out to be same as this. Okay, 4 and 4 are equal. Next we have alpha beta plus beta gamma plus gamma into alpha. So alpha is 2, beta is 1 plus gamma 1 into 1, and then we have 1 into again 2. So it is coming out to be 2 plus 1 plus 2, which is 5. Okay, and what is c upon a? Now c is here 5, so 5 upon 1. This is also coming out to be 5. Both are equal. Last we have product of zeros, alpha beta gamma. So alpha beta gamma product will be how much? 2 into 1 into 1. So the product is 2. And if we find minus d upon a, d is again minus 2. So it is also 2. So this is also coming out to be equal. So we need to verify this only, that all these are coming out to be equal. Okay, so first part now you can do. Next we have second question of the same exercise. It says that find a cubic polynomial with the sum of the product of its zeros taken 2 at a time and the product of its zeros as 2, minus 7 and minus 14. So let us first understand the language. First one of them is sum. So this is the sum, basically s, which we have denoted by s. So alpha plus beta plus gamma, this is given to be 2. Next we have sum of the product of its zeros taken 2 at a time. So this was denoted by s1 here. So alpha beta plus beta gamma plus gamma alpha. So this sum we are denoting it by minus 7. Next we have product, this is given to be minus 7. Next is product alpha beta gamma, this is given to be minus 14. So what was the formula for this polynomial? It was x cube minus sx square plus s1x minus p. So we just have to substitute the values. So it will be x cube minus 2x square minus 7x, because plus minus will be minus, and plus 14. So this is the required cubic polynomial. Question number 3 of the same exercise is, if the zeros of the polynomial x cube minus 3x square plus x plus 1 are a minus b, a plus b, we need to find the values of a and b. So let us name the polynomial by px here. So polynomial is x cube minus 3x square plus x plus 1. So the zeros are given by alpha is a minus b, beta is a, and gamma is a plus b. So let us denote the coefficients by capital letters. Okay, so because small letters are appearing here, so capital letters: a is 1, b is minus 3, c is 1, and d is also 1. So let us first find sum. What was sum? What will be sum here? Alpha plus beta plus gamma. We know that this sum is actually equal to minus b upon a. So if we substitute the values here, alpha is a minus b, a plus b, and minus of b. What is b here? Minus 3, and this is 1. So right side is 1. Now b and b will cancel. 3a is equal to 3. So the value of a is coming out to be 1. Okay. So for finding the value of b, let us find product. Let us see if we get the answer from this only. Alpha, beta, gamma. So this was minus d upon a. So what is d here? D is 1 here. Okay, so minus 1 upon a is also 1. So this right side is 1. Alpha, beta, gamma. What was alpha? The value of alpha was a minus b. Beta is a. Gamma ki value is a plus b. So if you put a as 1 here, so you will get what? 1 minus b into 1 into 1 plus b. So if you solve this, you apply the identity a minus b, a plus b, get a square minus b square equal to this. So minus b square is coming out to be minus 1 minus 1. So minus b square is coming out to be minus 2. So b square is 2. Now we have two values of b. Okay, एक value नहीं आएगी, we'll have two values. A will be either root 2 or minus root 2. So these are the two pair of answers. A1 b root 2. This is the first answer, first possibility, and the second possibility is A1 b minus root 2. Now let us continue with this exercise. Next question is question number 4. It says that if two zeros of the polynomial this are this 2 plus minus root 3, we need to find the other zeros. So this came in board exam also. So this is very important. This is from optional exercise. It is similar to the question. It is similar to question number 3 of exercise 2.3, in which two zeros were given and we need to find the other two zeros. So the first, let us first name this polynomial x4 minus 6x cube minus 26x square plus 138x minus 35. So the zeros are given by alpha is 2 plus root 3 and beta is 2 minus root 3. So we are going to follow a different approach here. Let us name the polynomial which we can divide, and the remainder will be 0. Let us name this polynomial gx, and you know how to find this polynomial. It is given by this. So for this polynomial we have to find s and p. What will be s here? If you find the sum of these zeros, you will get 4. This will cancel, and the product will be 2 plus root 3 into 2 minus root 3. So if you apply the identity here, you will get 2 square minus root 3 square. So it will be 4 minus 3, which is 1. Okay, so we can get this polynomial straight away. It is x square minus s. S is 4 and p is 1. So this is the polynomial. Now let us perform the long division like it was done in that question also. So after performing the long division, let us see what we get. So we are going to divide this by x4 minus 6x cube minus 26x square plus 138x minus 35. So first we'll multiply it by x square to get x4 minus 4x cube plus x square. So after solving this, changing sign, this will cancel. This will be minus 2x cube minus 27x square plus 138x. Okay, so now you have to multiply this by minus 2x. So next you will get minus 2x cube plus 8x square and minus 2x. You can copy down minus 35 also. After changing the signs, again this will cancel. This will be minus 35x square. This will be 140x minus 35. Now next step will be to multiply this by minus 35. So this is minus 35x square plus 140x. You can multiply this and get 140, and last will be minus 35. This is exactly same. So after changing sign, all will cancel, the remainder is 0. We already know that the remainder is coming out to is going to come 0 only. Okay, so now again that divisor algorithm, px equal to divisor into quotient plus remainder. Obviously remainder is 0 here again, so plus 0. Now for finding the other zeros, isko jab 0 put karenge, we'll get the same zeros. Okay, so we put for other zeros for other zeros, we will put x square minus 2x minus 35 equal to 0. Now again you can perform long division, you can perform middle term splitting here. So 35k factors will be 5 and 7. So you can clearly see that after subtracting these two, you are getting 2, but we need minus 2, so the factors will be 7 and minus 7 and 2. So x square minus 7x plus 2x minus 37 and 5. The factors will be 7 and 5. So x square minus 7x plus 5x minus 35 equal to 0. So x is common, x minus 7 plus 5 is again common, x minus 7 equal to 0. So x minus 7, x plus 5 equal to 0. So the other two zeros are coming out to be 7 and minus 5. These are the other two zeros. Okay, so let us do another question. Next we have question number 5 of exercise 2.4. It says that if the polynomial x4 minus 6x cube plus 16x square minus 25x plus 10 is divided by another polynomial, the remainder comes out to be x plus a. So it is given that on dividing this polynomial by this, the remainder is given to be x plus a. So we need to find the values of x, k and a. Okay, so let us do the long division here. Okay, so we have to divide the polynomial by x square minus 2x plus k, and we have to divide the polynomial, this polynomial. Okay, x4 minus 6x cube plus 16x square minus 25x plus 10. Let us do the division. So first step will be to multiply it by x square. So we will get x4 minus 2x cube and plus kx square. So if you change sign, you will get, this will cancel, this will be minus 4x cube, and this will be, you can take x square common out of these, so it will be 16 minus k x square minus 25x plus 10, we are just copying down. Okay, so next step will be to multiply this by minus 4x. Now if we multiply this by minus 4x, you will get what? Minus 4x cube plus 8x square and minus 4kx. Again if you change sign, plus minus plus, this is again going to cancel. This will be how much? You can take x square common, so this will be 16 minus k minus 8. So 16 minus 8 will be 8. So it can be written as 8 minus k into x square after simplifying this. Okay, and what about this? This will be minus 25 plus 4k, and x is same, plus 10 is again copied down. Okay, so next step will be to multiply this by 8 minus k. So this will be 8 minus kx square, then minus 2 times this. So you can multiply 2 inside, it will be 16 minus 2k. Okay, we have just taken this minus sign here and we have just multiplied 2 by this. Okay, next will be, x is obviously same, and next will be k times 8 minus k. Again if you change sign, minus plus and minus, this is again going to cancel. If we simplify this, this will be minus 25 and plus 16. So that will be basically minus 25 plus 16 will be minus 9. Okay, and plus 2 minus 4k, and it will be plus 2k. X is exactly same, and this will be changed to 10. 10 is the from this side, from this you have 10, and then we have plus 8k minus k square. So this is the remainder which we are getting, and the remainder is given to be x plus a. Now remainder is given to be x plus a, and what we have calculated, minus 9 plus 2k times x plus 10 plus 8k minus k square is equal to x plus a. Okay, now if you compare these two terms, if you compare this, you will get minus 9 plus 2k will be equal to x, the coefficient of x is 1 here, and 10 plus 8k minus k square will be equal to a here. Okay, and if you solve this, 2k will be 10, the value of k is 5. You put a as 5 here, k as 5 here, so a will be equal to 10 plus 8 into 5 minus 5 square. So this will be 50 minus 25, so the value of a is 25. So this was the way to calculate the value of k and a. Okay. So this is the end of this chapter, chapter number 2, polynomials.